Hello everyone. I will now spend some time in solving question number 5, which is a graphing question. However, it's a little bit different in the sense that they've given us 4 different graphs and 4 different functions above. We have to match each of these graphs with the correct function, with the function that each of these graphs correspond to. Now, I'm not going to give you the solution for this problem. However, I will be giving you some hints in how to go about solving the problem. I expect you to solve some of the problems in the project yourselves because the project has points assigned towards your final grade and you should be working on these problems yourselves. I've given you the solutions for many of the problems in here because this project is meant to prepare you for the tests. But for some of them, I still expect you to work and find the answers yourselves. All right, but let me give you some hints here. The first step would be to study each of these graphs and also the functions given above. We see for the first 2 graphs, they follow the shape and the direction of the tangent function. Now the graphs in number 3 and number 4, they have the shape of the tangent function, but the direction is not that of the tangent function. They look more like the graphs of the cotangent function. However, none of these functions above have the cotangent function in it. Therefore, if it's a tangent function, then it's probably a reflection of the tangent function. Now, when is a function reflected? When there is a negative sign before the function, right? So, for the function number 3, y equals negative tan of x, this suggests a reflection of the tangent function vertically across, and same for number 4, the 4th function, which is y equals negative tan of x minus pi over 2. So most likely these 2 functions will map to graph number 3 or graph number 4. Now you have to go about eliminating one of them and choosing the correct function for graph number 3 and 4. So I've narrowed it down to number 3 and number 4. You have to choose from one of these graphs carefully and make the right selection. For number 1 and number 2, there's no reflection involved, so the functions that would map to them would either be the first one or the second one. Again, you will have to work through the steps of eliminating and choosing the correct function for each of these graphs. All right. Now, in order to do that, the best thing would be to locate the asymptotes for each of these functions and then check whether the asymptotes in the graphs match with the asymptotes you found for each of these functions and make the right choice. What is the formula to find the asymptote? It would be bx minus c equal to negative pi over 2 for the left-hand side asymptote. The other one would be bx minus c equal to positive pi over 2. You will solve for x in these equations and that will give you the location of the left-hand side and the right-hand side asymptotes, and then accordingly you will check where the asymptotes of each of these graphs are, whether they match the asymptotes you found for each of these functions, and make your selection. All right, so this is how you will go about solving this problem. First, check for the shape and the direction of the graphs. If there's a reflection involved, choose the ones that have a negative sign in the function, and then find the location of the left-hand side and right-hand side asymptotes by solving the equation bx minus c equals negative pi over 2 and bx minus c equals positive pi over 2, and go about completing this question. All right? Hello, everyone. We will now talk about question number 6 in project 2. However, I will not be giving you the answer or the solution directly for these questions in this part of the video solutions. You will have to work them out yourselves, but I will provide some hints which you can use to go about solving these problems. Now this question says, use each graph to obtain the graph of the corresponding reciprocal functions cosecant or secant, as the case may be, give the equation of the function for the graph that you obtain. So you will have to draw the graph of the cosecant or the secant, the reciprocal function graph of the given graph, and you also have to write the corresponding equation for the reciprocal function. So the graph given to us is that of a sine function. It's y equals 3 times sine of 4x. We will have to use this graph as a guide to draw our cosecant function graph. Cosecant is the reciprocal of the sine function. Therefore, the graph that we are going to obtain will be that of the cosecant function. Now, we have to follow some steps in order to come up with the graph of the cosecant function for this particular function, the y equal to 3 times sine of 4x function. It must be the corresponding reciprocal function of this particular equation. All right. The first thing is to locate the asymptotes of the cosecant function graph. The asymptotes of the cosecant function would be located wherever the x-intercepts are of this sine function graph. Therefore, let's locate the x-intercepts of this given graph. We have an x-intercept at negative pi over 4, another one at x equal to 0, then we have one at pi over 4, and then another one at pi over 2. Now, the period of the cosecant function will be the same as whatever the period is of this particular sine function. All right. So once we have located the x-intercepts, we draw our asymptotes with dashed lines passing through these intercepts. And once we have that, the next step would be to draw the cosecant graph. You have to remember the shape of the cosecant graph, and the minimum point of the cosecant graph above the x-axis would be wherever the peak point or the maximum point of the sine function graph is located. Therefore, our cosecant graph will come down to the maximum point of the sine function graph given to us and then go up again all the way to infinity along the asymptote on the right hand side. Below the x-axis, the cosecant function will have its maximum point wherever the minimum point of the sine function graph is located. Therefore, it's going to look something like this. All right. Now, you also have to come up with the equation. Equation is going to be the same as the given equation here, except that instead of sine, you have to have the cosecant function mentioned. All right. So that is how you're going to go about solving question number 6 as well as question number 7. Question number 7 is a similar problem, only that it's a different function. It's the function of a cosine graph. You have to come up with the reciprocal of the cosine function graph given here. The reciprocal of the cosine is the secant. Follow the same steps. First, locate the x-intercepts of the given graph. So we would have one here, another one here. Locate the intercepts. Draw your asymptotes passing through the intercepts, and then draw the secant graphs. Secant graphs have the same shape as the cosecant and will have its minimum and maximum points wherever the maximum and the minimum points of the cosine graphs are located. All right. So just follow the same process that I talked about for the cosecant function graph above. All right. The next set of questions is really on the inverse trigonometric functions. The first set of questions is asking you to give us the restricted ranges of each of these sine, cosine, and tangent function. The sine function has an inverse function within the restricted range of x, or between negative pi over 2 and positive pi over 2. The cosine function has an inverse function between 0 and pi. For the tangent function, it's same as the sine function, so negative pi over 2 and positive pi over 2. Remind yourself what we mean by an inverse function. In an inverse function, we are really looking for the angle measures. When somebody asks you to evaluate an inverse function, the answer that you come up with should be an angle measure, either in degrees or in radians. Most often it is in radians, all right? And these are the ranges within which the angle measures will be located. So when we say the restricted range of the sine function is between negative pi over 2 and positive pi over 2, we refer to the first quadrant or the fourth quadrant angle. Therefore, the angle measure for the inverse sine function would be an angle value either in the first quadrant or in the fourth quadrant. For the cosine function, it would be an angle measure either in the first quadrant or the second quadrant, 0 and pi. Therefore, it would either be 0 is here, pi is here, pi over 2, and then we have 3 pi over 2. Now, on the negative side, this 3 pi over 2 corresponds to negative pi over 2, and then we have negative pi, and this becomes negative 3 pi over 2, correct? So when we say that the cosine function would have an inverse function between 0 and pi, we refer to the first and the second quadrants. For the sine function and the tangent function, it's negative pi over 2 and positive pi over 2. That would make these two quadrants. Therefore, first and fourth quadrants for the tangent function as well, just like with the sine function. Only with the cosine function, it's an angle measure either in the first quadrant and second quadrant because its restricted range is located between 0 and positive pi. Now, the next set of questions is to evaluate inverse sine functions. So the first one, for example, says, find the inverse sine of negative half. Now, when you answer these questions, you are not allowed to use calculators, all right? You have to know your special angles table and know what you are really trying to find. When it says inverse sine of negative 1/2, that means you're being asked to find an angle value whose sine ratio is negative half. Likewise, when the question is inverse cos of 0, that means give us the angle measure whose cosine ratio is equal to 0. Same for the inverse tan function and so on. So just remind yourselves every time you answer these questions that you are really finding an angle measure whose tangent or sine or cosine function has the given ratio. All right? And you also have to remember those intervals within which the function would have an inverse function. Therefore, if it's an inverse sine function, the ratio given to us is negative half, correct? Therefore, this cannot be a first quadrant angle because in the first quadrant, all sine ratios are positive. It must be a fourth quadrant angle. It cannot be a third quadrant angle either. So for that, you have to remind yourselves of the restricted ranges within which a function has an inverse function. For the tangent function here, inverse tan of negative square root over 3, you will provide an angle measure in the fourth quadrant because inverse tan is valid only within the range negative pi over 2 and positive pi over 2. Because the ratio given to us is negative, it will be a fourth quadrant angle and not a first quadrant angle. All right. So this is how you will go about solving these problems. Please refer to the lecture videos or to your textbook. They have worked out examples as well, and you can follow the steps shown there to solve these problems. And towards the end, we have some composite functions. For example, it's the inverse cos of 2 pi over 3. Please review the rules of the composite functions when you answer these questions. All right?